Hello, I'm David Noel. Welcome to episode 01 of SMB. The topic today is the expanding universe. Here I'll show why the idea that the universe is expanding is a myth and how this myth arose. Over the years, telescopes have become more and more powerful, letting us see further and further into space. The idea that the universe is expanding came about during the 1930s, some 90 years ago. The American astronomer Edwin Hubble had the use of a new telescope, which was able to make out more and more of the galaxies which surround our home galaxy, the Milky Way. The light coming from a distant galaxy can be split up into its constituent colours in a band called its spectrum. The top third in this graphic is a spectrum band with the colours spread out from violet on the left to red on the right. On the spectrum of a distant astronomical object, there usually appear a number of dark spectral lines caused by absorption of light by a particular element, such as hydrogen. Edwin Hubble discovered that if the spectrum was from a distant galaxy, bottom band, these spectral lines were shifted towards the right-hand red side compared to the spectrum from a close galaxy. What's more, the further away was a galaxy, the greater the shift. This shift in spectral lines is what's called the Galactic Red Shift. When it was discovered, naturally enough, the hunt was on to work out what caused it. At that time, the brilliant Swiss-American astronomer Fritz Zwicky examined all the likely causes of the red shift. He concluded that the most likely cause was that light lost a tiny bit of energy as it moved through interstellar gravitational fields, and this showed up by a small shift in frequency towards the lower red end of the spectrum. He called this gravitational drag. Zwicky was a huge figure in the astronomy of the 1930s and 1940s. He predicted the existence of neutron stars and originated the concepts of supernovas and dark matter. Nevertheless, one of the explanations which Zwicky had discounted gradually gained popularity. This was the idea of Doppler shift. The Doppler effect is the change in the apparent frequency of a wave when an object is moving away from you or towards you. Take the example of the sound wave from a car or train as it moves in from a distance, comes close and passes, and then moves away. The sound changes in pitch from high to medium to low. This is because, as the sound source moves towards you, the sound waves are compressed, appearing as a higher frequency, while when moving away from you, they are stretched. The same thing happens with light. Off is slightly compressed, making it appear more blue. The star Arcturus is moving away from us, and so its light is slightly reddened. The size of the shift tells us the speed of approach or recession. When the light from distant galaxies was examined, their spectra all showed red shifts, and so the mistaken belief arose that these galaxies were receding And this was how the expanding universe myth arose. We'll go on now to use the laws of physics and common sense to show why the idea of an expanding universe must be a giant error. According to this myth, the universe expanded to its present size from a single point in a giant explosion, the Big Bang, around 13.8 billion years ago. First point, on compression. Because the light we receive from distant objects travels at the speed of light, a fixed quantity, the images we have of galaxies 1, 5 or 10 billion light years away shows them as they were 1, 5 or 10 billion years ago. If the universe had actually expanded, then clearly its parts were much more compressed, much closer together in the past than they are now. So if we look further and further out into the universe, with the aid of increasingly powerful telescopes, we should see the older parts being much more compressed. This is just not the case. Whatever part of the universe we look at whatever age, the distribution of stars and galaxies within it is pretty much the same. According to the expanding universe myth, around, say, 7 million years ago, the universe was about twice as compressed as it is now, and galaxies around 7 light years away should be packed twice as tightly as now. This just isn't what we see. Second point, on gravity. If the universe had really expanded, then in its earlier compressed state, the laws of gravity would have to be quite different for an object like a galaxy to maintain its shape, and these laws would have had to change continuously to keep up with the expansion. There's no evidence at all that such a thing happened or is still happening. Moreover, if the universe had any sort of outer boundary, gravity will be acting to pull the whole universe towards its centre of gravity. The universe will be gravitationally unstable. There's no evidence of this either. Third point, on the red shift. If you look again at the shifts shown between the upper and lower bands, for close and more distant galaxies, you will see that the size of the shift is not the same for the whole spectrum. The shifts on the right-hand side are greater than those on the left. In fact, galactic red shifts are exactly proportional to wavelength. The light at the red end of the spectrum has almost twice the wavelength of that at the violet end, and so the shift is almost twice as great. This demonstrates conclusively that galactic redshifts cannot be due to a Doppler effect. In the Doppler effect, the size of the shift depends entirely on the relative speed of an object relative to an observer. If the redshift observed for a galaxy was actually due to Doppler, then the red parts of that galaxy would have to be moving away from you almost twice as fast as the violet parts, an obvious impossibility. So here then are 3 of the main evidence points on why the expanding universe theory is false, why it is a myth. Number 1, if we look at images from the far distant universe, by virtue of the light emitted billions of years ago, they are not compressed as the theory would have it. 2. With galaxies and other universe components packed much more tightly together, the normal laws of gravitation could not retain the shapes and layouts actually seen. Number 3. Actual redshifts on the spectra of distant galaxies are not of the right form for them to represent Doppler expansion, as it would mean different parts of the same galaxy will be receding at different rates. Point 3 is a killer point. If you know of a scientist who still believes in an expanding universe, you could ask them to explain how redshifts from the same object can be different for different parts of their spectrum. Okay, now we've shown that the universe is not expanding. We can have a quick look at the real situation. There will be more detail on this in other episodes. We'll just look at a couple of the ground rules. Rule 1. The universe is infinite in space and time. It does not have a beginning or an age, and it does not have outer boundaries, now or in the past. Individual components, like galaxies or stars, are born, live and die, each according to their own situation, but the large-scale appearance remains the same. Number 2. Galactic red shifts occur because gravity exerts a tiny drag on light travelling through the universe, so it loses a fixed proportion of its energy for each unit of distance it travels. This effect of light and gravity is well known and accepted in other situations, such as the gravitational redshift, which sucks energy out of light rising from a massive star, or gravitational lensing, which bends light from behind a massive object. The quantitative amount of this energy loss is given by the Zwicky constant, which is the distance that light needs to travel in the open universe for it to lose half its energy. This distance is quite large, about 7.7 billion light years, which is about half the current limit of our telescopes. Following are some links to other sources available to you, both episodes on our YouTube channel and a website including articles which quote established and reference data. Have a look. But episode 02 on the Big Bang is closely linked with this episode, and it might answer some of your queries. So it's goodbye from me, David Noel. Keep well.